Okay, mathematicians, next curve we have a look at is the function y equals the square root of x. So remember, if we just say square root of x, the implication is that this is the positive square root of x that we're talking about. And I think maybe we could jump straight to the GeoGebra and have a look at this. So if we look at y equals the square root of x, then that's this curve, which is the upper half of a parabola lying on its side. So for this one, the domain, the set of x values which the graph obviously exists for, and which we can put into this equation, are x values greater than or equal to 0. And the y values are going to always be greater than or equal to 0 as well. Y equals minus x, as you might be suspecting, is the bottom half of the parabola. So once again, the x values that we can put into this equation are x greater than or equal to 0, but the values that we get out are all going to be 0 or negative. So the range is y less than or equal to 0. Now either that or that are functions, but if we get rid of those and instead we imagine squaring whichever one of these, we would get y squared equals x. And when we do that, that's the entire parabola lying on its side. And clearly that would fail the vertical line test, so it's a relation, not a function. For what it's worth, it still has a domain x greater than or equal to 0, but the range is all real y. But talking about domain and range for relations is not usually as useful as talking about it for functions. So if we jump back to our notes, we covered all that we really need to at this stage for the function y equals root x. So we'll move on to circles and semicircles. Okay, for circles and semicircles, I guess in a way you just have to take my word for it at the moment that this is the equation for a circle. And the centre of the circle is at A and B, and the radius of the circle is R. Later on in the course you will actually see how that's derived, but for the moment we'll take it as given. Notice, as we've pointed out somewhere along the way, the circle is a relation, not a function, because it fails the vertical line test. So let's quickly look at the GeoGebra. So here we have our circle, centre AB, radius R, and in this case A is minus 1, B is 2, so our formula becomes x minus minus 1, in other words x plus 1 squared, and y minus 2 all squared. So the centre has moved one place to the left and 2 places up, and the radius is going to be 2. Now, if I just do the obvious, if I increase the radius, then the circle gets bigger, as we'd expect. And if I move A so that it has the value 0, and B has the value 0, then that's my circle centred on the origin, and in this case of radius 3. And its formula would be, we usually don't write it with the minus zeros, its formula would just be x squared plus y squared equals 9. And clearly it would fail the vertical line test. Now just as up above, we could take the parabola lying on its side and divide it into a positive square root and a negative square root. We can do the same with the circle, and we get the semicircles. So a semicircle is going to be, if it's for this circle centered on the origin and radius r, the positive semicircle will be what we get when we make y the subject. So y squared equals r squared minus x squared. We take the square root of it, and when we take the positive square root, we've got the top semicircle, this one here. And when we take the negative square root, we've got the lower semicircle. So if we added those two semicircles together, so we counted both square roots, then that of course would be the full circle. So if we think about that about the full circle, we can see that for this particular example, the domain is -3 to +3, the range is -3 to +3. If we think about this positive semicircle, domain is still -3 to 3, but the range is 0 to 3, and likewise for the negative semicircle. So a quick look at that on GeoGebra. So if we let the radius be, well, let's just bump it up a little to be 4. So you can see that what that does for my equation, x squared plus y squared equals 4 squared. So that's our full circle just there, a relation. And if we just do the positive square root of that for y, that's our positive semicircle and our negative semicircle.